7a, we're going to look at function operations. So adding, subtracting, multiplying, and dividing functions or equations. Okay, so when we do this, we're going to look at the domain of the new function that we create when we add the two together or subtract the two or whatever operation we're doing. Okay, and so most of the time in most of the functions that we look at, the domain is all real numbers because the graph, remember, domain is x values, and the graph goes to the left forever and goes to the right forever for most of them, but not all of them. So the two most common things that we're going to look for things that might cause what we call restrictions in the domain, meaning numbers that we can't put in for x. One of those things would be a square root. Okay, so we know that if I have like the square root of -4, that's an imaginary number, that's not a real number. We're not going to graph imaginary numbers in Algebra 2. So we would say that x cannot be anything negative if there is a square root. The second place that there might be a restriction that we're going to look for is anytime we have a fraction. Okay, remember that the bottom of a fraction, the denominator, cannot be 0. Okay, because if I have something over 0, that is undefined. We can't divide by 0. So I'll show you a couple examples. Let me get to the right screen here. Okay, so this is just a line, y equals 3x. Okay, it goes left forever, it goes right forever, so there would be no domain restrictions there. Another popular graph that we look at are parabolas. Again, they go left forever, they go right forever. All right. The square root graph, though, remember, it stops at 0 because we can't put any negative numbers in there. So those would be domain restrictions. Everything would have to be positive. X would have to be greater than or equal to 0. This is the graph. I'm not sure if you guys can see the equation. So this is the graph of 1 over x. Okay, and so if I look at this graph, even though it looks like it's touching 0, it's actually not. If we were to zoom in really close, you can see it's actually never going to touch that line. It's going to keep going up forever without ever touching that line. And then same thing going in the other direction, if I can get down there. Yeah, as we go to negative numbers, see, this is going to keep getting closer and closer to 0, but it's never going to actually touch that line because that equation that was graphed is 1 over x, and I can't put 0 in for x. All right, so my domain there can be any number except for 0. Okay, so those are two things that we need to look out for when we're doing these problems. All right, so the first example we're going to look at is adding and subtracting. So f of x is 4x plus 7. G of x is the square root of x plus x. And we're going to do f plus g. So I'm going to put them in parentheses. 4x plus 7, that's f, plus g is the square root of x plus x. Okay, and now it's just like in Algebra 1 where you added and subtracted polynomials. We're looking for like terms that we can combine. So I can combine 4x plus x here. That would give me 5x. All right, 7, there's no like term over there, so I'm just going to keep it, 5x plus 7, and then plus the square root of x, because there's no like term that I can combine with that. So this is f plus g of x. This is my equation. All right, and the domain of that graph, well, what restrictions does it have? This 5x part, that would be no restrictions. I could put any number in for x there, but in this part, the square root of x, I can't put negative numbers. So we would say that x is an element of the real numbers where x is greater than or equal to 0, because no negative numbers would go in there. Okay, here, same thing, we're going to do f minus g. So I'm going to do 4x plus 7. That's my f. All right, and that's going to be minus the square root of x plus x, because that is my g, f minus g. Remember, when you're subtracting fractions, the easiest way so that you don't get confused is to distribute that as a -1. So now I have 4x plus 7 minus the square root of x minus x. and then we're combining like terms. So 4x minus x is 3x, and then these still don't have like terms that go with them. All right, and it would be the same thing here for my domain. X would be an element of the real numbers, but it has to be greater than or equal to 0. Sorry, that should be an x. Greater than or equal to 0 because I cannot put negative numbers underneath that square root. Okay, so here's the second example. I want you to pause here and give this a shot on your own. Okay, so there's your solutions for this example. And the domains here are both x is an element of the real numbers because there's no restrictions in either of these graphs. They would be parabolas. They would go left and right forever. All right, so next thing we're going to look at is multiplying and dividing. So same as we did with adding, subtracting, I'm going to write them in parentheses. So f times g, well, f is x squared minus 9. And that's getting multiplied by g, which is x plus 3. And then we have to FOIL this, all right? So x squared times x is x cubed. X squared times 3 is 3x squared. Negative 9 times x is negative 9x. And negative 9 times 3 is negative 27. I have to double check there. There are no like terms, so that's going to be my function. And then the domain, I have no fractions and I have no square roots, so that domain is going to be x as an element of the real numbers. Okay, f over g. So now I'm going to have f divided by g. Okay, anytime we have fractions, we need to have these functions be factored. Okay, so x squared minus 9 can be factored. That is a difference of squares. So it is going to be x plus 3 times x minus 3. That is it factored. And then that goes over x plus 3. Okay, so what that means is these two factors are exactly the same. So I can cross them out, and the simplified f over g would be equal to x minus 3. However, when I did this division, I had a fraction. So anytime I have a fraction, the bottom of that fraction cannot be equal to 0. All right, what number, if I plugged it in for x, would make this whole bottom thing equal to 0? All right, well, that would be negative 3. Sometimes this one is pretty easy to figure out, but if the bottom starts to get more complicated, the way that we would do it is take the denominator, the bottom of the fraction, and set it equal to 0, and then solve. All right, so x plus 3 equals 0. I would subtract 3 from both sides, and x would be equal to negative 3. Okay, that means that I cannot put negative 3 in for x in this equation because it would make the bottom 0, which is undefined. So my domain is all real numbers, except that x cannot equal negative 3. So it can be any number except for negative 3. That one doesn't work. Okay, so we're going to do the same thing with this last part. I want you to pause here, try it on your own, and then we're going to come back and check your answers. Okay, so there are your simplified functions for these two examples. All right, there are your domains. Make sure you double check there, and if you have any questions, write them down so you can ask in class. And that's it for 7A.